Now we will understand the dependence of state of matter on its temperature. Actually, state of matter depends upon the conditions of temperature and pressure. But here we are assuming that the pressure remains constant and the temperature of matter is changing. Basically, we take only three states of matter, namely solid, liquid and gas. Say we are having a solid and the solid is heated. When solid will be heated, then its temperature will increase. Means average kinetic energy of its molecules will increase, and it will increase only up to a certain maximum value, and that certain maximum value of average kinetic energy of molecules in solid state will be equal to the minimum average kinetic energy of molecules for its liquid state. And in that condition, temperature of solid will become constant, and that temperature will be the melting point or fusion point of solid. At that temperature, heat will be supplied to the solid, but there will be no rise in its temperature. That's why the heat supplied to the solid at its melting point will be called hidden or latent heat. So this latent heat will only change the state of solid from solid to liquid without changing its temperature. The constant temperature at which a solid will change into its liquid state by continuous absorption of heat will be called melting point or fusion point of solid, while the process in which a solid changes into its liquid state at a constant temperature with continuous absorption of heat is called melting or fusion. When the solid melts completely, it will convert totally into its liquid state, and if now this liquid is heated, then on heating the temperature of liquid will increase. Again, this increase in temperature will cause an increase in average kinetic energy of molecules of liquid. This increase will be up to only a certain limit, and at that limit the temperature of liquid will be called its boiling point or vaporization point. At that temperature, average kinetic energy of molecules of liquid will be maximum, while this maximum kinetic energy of molecules of liquid will be equal to the minimum average kinetic energy of molecules of its vapor state. It means again a constant temperature will be attained by the liquid. This constant temperature will be called its boiling point or vaporization point, and heat supplied to the liquid at its boiling point will not be utilized by the liquid to raise its temperature. It will be utilized only to change its state from liquid to vapor state, and again this heat will be latent heat of vaporization or latent heat of ebullition or boiling. The constant temperature at which a liquid will change into its vapor state by continuous absorption of heat will be called its boiling point or vaporization point, while the process in which a liquid changes into its vapor state at constant temperature by continuous absorption of heat is called boiling or vaporization or ebullition. Now, if the vapors formed from the liquid are further heated, then on heating the temperature of vapors, that is average kinetic energy of their molecules, will increase, and hence the vapors will be called superheated vapors. Now, if these superheated vapors are cooled, it means heat is withdrawn from superheated vapors at a constant rate. Then the temperature of superheated vapors will come down to their condensation point, because this time vapors will change into liquid state. So instead of boiling point, we will say condensation point. Now at condensation point, the average kinetic energy of molecules in vapor state will be minimum, while average kinetic energy of molecules in liquid state will be maximum. It means that will be the maximum temperature for liquid state while minimum temperature for vapor state, and the constant temperature at which vapors will change into their liquid state by continuous evolution of heat will be called condensation or liquefaction point. The process in which vapors change into their liquid state at constant temperature by continuous evolution of heat is called condensation or liquefaction. Also, if vapors have changed into their liquid state, then on further cooling, temperature of liquid decreases, and means average kinetic energy of molecules of liquid decreases, and this will decrease until the liquid attains a constant temperature called freezing point of liquid, and this freezing point of liquid will be numerically equal to the melting point of solid. It means the temperature at which a solid changes into its liquid state will be equal to the temperature at which same liquid will change into its solid state. Hence, the melting point will be numerically equal to freezing point, and at freezing point, average kinetic energy of molecules in liquid state will be minimum, while this average kinetic energy of molecules will be equal to the maximum kinetic energy of molecules in solid state, and the constant temperature at which a liquid will change into its solid state by continuous evolution of heat will be called freezing point of liquid, and the process in which a liquid will change into its solid state at a constant temperature by continuously losing heat will be called freezing. If a solid directly changes from solid to vapor state by continuous absorption of heat, then the process is called sublimation. In the same way, if vapors directly change into their solid state by continuous evolution of heat, then the process is called Hoarfrost. Now the next thing, latent heat. Latent heat is the amount of heat required by a substance to change its state at constant temperature. This latent means hidden, and it is expected that on supplying or taking heat from a substance, its temperature should change. But we know during change of state, heat is either supplied to the substance or is taken away from the substance, and there is no change in its temperature. Hence, the heat utilized to change the state of a substance is called latent heat. Now, its SI unit will be joule only. During change of state, heat utilized, that is, the latent heat is always utilized in breaking the intermolecular bonds, that is in increasing the intermolecular separations, and if intermolecular separations increase, then potential energy of molecules increases. Thus, the heat supplied during change of state is utilized to increase potential energy. Thus, the kinetic energy, that is temperature remaining the same, increase in potential energy in the form of latent heat increases the internal energy of substance. Thus, internal energy of a solid at its melting point will always be less than the internal energy of its liquid state at melting point. As their temperatures are same, average kinetic energies of their molecules will be same. But since the liquid state has attained some extra heat, that is latent heat, which is stored in it in the form of potential energy, the internal energy in liquid state at melting point will be more than the internal energy in solid state at melting point. Similarly, the internal energy of substance in vapor state will be more than the internal energy in its liquid state at boiling point, because at boiling point the heat supplied, that is the latent heat of vaporization, will increase the internal energy of the substance. Hence, the internal energy in vapor state will be more as compared to the internal energy in liquid state, even though their kinetic energies will be same because of same temperature called their boiling or vaporization point. Next thing is specific latent heat. What is specific here? Here mass is specific. The mass is unit. It means specific latent heat is defined as the amount of heat required by unit mass of a substance to change its state at constant temperature. That is, amount of heat required per unit mass is specific latent heat. It is represented by L. So L is equal to amount of heat required per unit mass to change its state at constant temperature. And this implies heat required to change state is equal to M into L, that is mass into specific latent heat. Here heat will be measured in joule while mass in kilogram. So SI unit of L will be joule per kilogram, that is J kg minus 1. Now this expression dq is equal to ml will always be used whenever there will be change of state with heat transfer. Whenever there is change of state with change in temperature, we will use amount of heat transferred is equal to mass into specific latent heat. And also, if there is change in temperature with heat transfer, then amount of heat transferred will be measured by delta Q is equal to mc dt. Specific latent heat of vaporization of water is 540 calorie per gram or 2268 joule per gram. It will be equal to specific latent heat of condensation of steam. Also, specific latent heat of fusion of ice is 80 calorie per gram, that is 336 joule per gram. The specific latent heat of fusion of ice is very large. That's why the cubes of ice are better cooling agent than the ice cold water, because every gram of ice for changing its temperature through 1 degree Celsius will require 336 joule of extra heat than the ice cold water. Hence, ice candies will feel more colder than the ice cold water. Also, the ice cubes will be better cooling agent than the ice cold water. Also, because of high specific latent heat of fusion of ice only, the ice on mountains melts slowly, providing us water in rivers throughout the year. Specific latent heat of vaporization is also very large, and this large specific latent heat of vaporization indicates that steam contains large amount of extra heat. Because of large amount of extra heat at comparatively low temperature, normally 100 degrees Celsius, the steam can be used to run the engines of trains, also to rotate the blades of turbine coupled to the generator in thermal power stations or nuclear power stations. Also, the steam iron is more effective than the dry iron because steam iron will provide steam that will have large amount of heat at comparatively low temperature. Hence, steam iron will be used to effectively straighten the fibers as compared to the dry iron. Also, burns caused by steam will be more severe than the burns caused by boiling water because every gram of steam on condensation will provide 2 to 68 joule of extra heat than the boiling water. So these are the few effects of high specific latent heat of vaporization and high specific latent heat of fusion of ice. Specific heat capacity of solid or vapors is less than the specific heat capacity of liquids, while specific latent heat of vaporization of liquid is always greater than the specific latent heat of fusion or melting of solid. Keeping all these points in mind, we can draw the heating or cooling curve for a substance. If you think this video is of any help for you, then please share it with your friends so that they may also be benefited by it.